an example of intermediate value theorem, IVT. Okay, what is intermediate value theorem says is, let's say there's a b point given and it's continuous. If the function is continuous from a b, and if f of a is not equal to f of b, then there's a value exists that between f of a and f of b. That is intermediate value theorem. Now let's look at some examples on that. Let's look at this first example. Let's say we have f of x function given that is equal to x cubed plus 4x minus 2, and we have 2 points given like 0 and 2. Find the interval. So to do that, first I have to plug this a b values. So here our a is 0, b value is 2. So if we plug this one, this is 0 cube plus 4 times 0 minus 2, and that's going to give us negative 2. And then if we plug b value, that's 2, f of 2, that's going to give us 2 cube plus 4 times 2 minus 2. 2 cube is 8, 8 plus 8, that's 16, 16 minus 2, that is 40. So from that we know that first one is negative 2. I write in a different color. So we have a value k exists in between negative 2 and positive 14. So there's value k exists in between negative 2 and 14. Now we can actually prove this one drawing a graph. Like if you draw a graph, if you plot negative 2, it's gonna be somewhere here. Let's say this is negative 2, and then let's say here we have 14. So if we cross, like if we draw the graph for this one, this is gonna be something like this. And you can see at some point we are having a value of 0. So that is between 0 is between this interval, given interval, right? Negative 2 and 14. So we can say there's a value exists that is f of c is equal to 0 and f of c is equal to k. So we can say k is 0 here. Okay, now let's look at another example. I'm gonna go ahead and erase everything. Okay, let's say we have a question given like this: f of x is equal to x square plus x minus 1, and they have given 2 points, that is 0 and 5. Okay, so they are, and also here a little bit different, they also asking like prove that f of c 11 exists within this within this. So to do that, first we have to find out the functions for these two given points. So we have to prove that f of c exists between the function that containing 0 and 5. So if we calculate these two values, let's see what we get. If we plug f of c 0, it's going to be 0 square plus 0 minus 1, so we get minus 1 for this. If we plug 5, it's 5 square plus 5 minus 1, that's 25 plus 5 minus 1. 25 plus 5 is 30, 30 minus 1, 29. So we are having a k value that is this here, negative 1, k value that is greater than negative 1 and less than 29. So of course 11 is between that. So we proved that 11 is within this range, that within these two values function range. And let's say if the question also asks us to find out what is, okay, also you have to know that f of c is k, f of c is k. If you want to find the c, you can actually, the question didn't ask that, but if you want, like, let's say if you have a question that asks you to find the c value, what you can do is you take the 11 and apply in this equation. F of x is 11 in this case, that's going to be equal to x squared plus x minus 1, and if you rearrange this one, it's going to be x squared plus x minus 1 minus 11, that's minus 12, that's equal to 0. Now here we have to get a number that is when we multiply negative 12, when we add positive 1. So 4 and negative 3 will work, because if you multiply this number you get negative 12, and when you add you get positive 1. So we can rewrite this one as x plus 4 times x minus 3 is equal to 0. Therefore x is equal to negative 4 and also x is equal to 3. We are having two values for the x value. Now which one is true, or is both of them true? Like, can we have both of them, or can we have, there's only one value possible? You have to look at this range, negative 1 to 29. This negative 4 is not included, so we cannot have this one. So this is our answer, like this is our c. C is equal to 3. Right, that's how we can find c value. And that's it for this video guys. Thanks for watching. See you guys on my next video.